Well, Dr. Lin, thank you very much for a great presentation and for leaving us with a lot to talk about, not just today, but over the summer and going into next fall. So I know people have put some questions into the chat, and we have some time in this hour to look at those questions. So let me go ahead and open up the chat.
Perfect.
And I will start asking you some of the questions. So one of the questions that came in was, obviously, sea level rise is going to impact another earthquake event, and those are tsunamis from earthquakes. And what can you tell us about sea level rise and increasing risk for earthquakes in the ocean due to sea level rise?
Yeah, so in fact, kind of one of the recent utility of our framework for probabilistic sea level rise hazard analysis in the structural engineering community was actually extending our framework to basically probabilistic tsunami hazard analysis incorporating our sea level rise. So what they did is basically extending our framework directly, like all the different GCM, the global circulation models, and then also the RCPs, or representative concentration pathways, all those sea level rise projections in terms of the exceedance probabilities, and then integrate into what they already have for tsunami. And what they see there is essentially all of this. If you think about this, is really like a multi-hazard scenario. So for instance, sea level rise alone, you can think about it as a one hazard, but really is what sea level rise on top of something else, for instance, tsunami that are really damaging. That's one example. Another one could be also sea level rise and storm surge. So basically all the compounding effects. If you think about all those hazard curve, you could have hazard curve or hazard maps for earthquake, for storm surge, for tsunami, all of that. But sea level rise basically just add on top of it a much higher probability of exceeding some of the current thresholds. And that's also what I think one of my students is going to talk about, for instance, in terms of flooding risk in Houston or the Gulf of Mexico.
Right.
Harvey in future.
Yeah, I mean, as part of the South Central Climate Adaptation Science Center that Texas Tech belongs to, we integrate with the group out of LSU that does a lot of work in terms of sea level, because obviously Louisiana is sort of the center for what's going to happen within the United States and has already been occurring. But one of the factors I think a lot of people don't realize, and I'm getting this from the LSU group, not only is sea level rise going to impact us directly in terms of cities and population migration, but also the ecological consequences, for example, dealing with mangroves around the world and the capacity of mangroves to deal with sea level rise and those low-lying areas around. I mean, that's a dynamic that not very many people talk about.
Yeah, totally. And that's also part of what we're thinking also, not just the problem itself, because also we're kind of trying to go back to the science, engineering, and technology theme here. So think about sort of like how we could perform all the hazard analysis to basically inform our decisions. And part of that is innovative solutions. So that could include kind of the typical civil structural engineering, just kind of building bigger, stronger to resist all the force and all that. But it could also include nature-based solutions. Some of those like what you covered. So basically like let nature have the defense rather than us trying to kind of enforce this and that.
No, and that's exactly right, because part of the group is looking at how do you reestablish mangroves in areas that humans have impacted to slow down the impact of sea level rise so it's not too immediate.
Exactly.
Right? Yeah. The other part of that, which is interesting too, is somebody mentioned on another meeting I've been at also that one of the things people don't realize about sea level rise is the impact on fisheries because of a lot of ocean fish needing estuaries and river systems to spawn in and to hold the fry. I mean, that's a consequence that nobody talks much about either, particularly the Grand Banks, the Gulf of Mexico, all those important fisheries for North America are going to be impacted also.
Yeah, indeed. I think a wide range of all those are going to be impacted by sea level rise. I guess a lot of those are the fisheries and also all the various ecosystems as well as I think a lot of the partners with the center also, they could be stakeholders who are really concerned about sea level rise, and they could potentially contribute to tie back to the previous, I think, Science by the Glass talk back last year in December by the director back then. It's really kind of some of this really hoping to have some co-creation of solutions. So, because we don't want to kind of force, as scientists, engineers, kind of force what we think would be good, but rather discuss with the communities, discuss with people and who are affected by this, and see what's important to them, and then together we can devise some future solutions. Yeah.
Yep. No, very wise. One of the questions that came into the chat has to do more with earthquakes. And could you speak about some ways people can protect themselves during earthquakes and other natural disasters?
Oh yeah, totally. So one resource you could go into is called Shake Out. So Shake Out. Let me just kind of cut here. So if you Google Shake Out, that's a outreach program. Okay. And basically from earthquake countries, but it's applicable for not just say typical places like California, but also, for instance, us here in West Texas too. I think we are also experienced some recent earthquakes here, although not big ones. So essentially being prepared is key. And Shake Out provides some very nice resources and also steps, what you can do before, during, and after. So that's a wonderful resource to look into. And USGS in general, I think does a pretty nice job in terms of education and outreach. And one of the other efforts I had previously not presented here today because it was more focusing on the climate science piece was also in my research group, we also did virtual reality.
Okay.
2014-ish. Yeah, it was a project funded by SCAG, Southern California State Center, jointly by National Science Foundation and US Geological Survey. That was basically, it's really random, as serendipity almost. It was actually, inspiration comes from pilot training. So when pilot tries to kind of learn how to fly, you would typically do like a ground simulation first to try to kind of land and all that. So I did a bit of that. And then I realized that really helped when you are in the sky. So I thought, why not just treat, I think this question of not just earthquake, but other natural disasters as sort of like a training, like emergency response training, where you basically have some sort of muscle memory before the event occur. So that's essentially the basis for that. So what we did there was connecting some of the more hardcore research from the geophysics piece, earthquake ground motion simulations, and to tall building response engineering piece, and then also to more like user friendly. So what we did there was try to model also your immediate environment, like your room, rather than the structure. If I tell you storage ratio and all that, that might not mean much to people. But if we simulate that, what we did was using game engine, like computer games, then you can see according to shaking, you can see, for instance, your bookshelf is shaking. And then that hopefully will inform you, saying, you know what, if this is happening, this is really not too good. Maybe you would want to tighten that up first, before the event occurs. So that's another way of like fun outreach and also preparedness.
No, very good. The earthquake question has a related one, particularly for West Texas, and that is, what can you tell us about fracking and the earthquakes in West Texas? Because I know there's been some information published on that.
Yeah. So that was I think that's a KCBD TV interview question for me previously too.
Right. Yes.
We had several events here. So in general, you could have various causes for earthquakes, right? Like you could have the natural ones that you have tectonics, you have the faults and all that. That's one possibility. Another one is basically fracking, right? Like, or the more the human-induced type, almost back to Gordon's definition of hazards, either as natural or societal. So there's possibility there. And then I think more, and specifically like which one is caused by which for specific earthquake, sometimes it's hard to tell. But overall, if you aggregate the data, then you will see some trends, right, over time. Yeah, and this is also a hot topic currently. in the research community.
Ting, within the state of Texas, who's responsible for dealing with sea level rise?
This is a good question. I would also love to find out.
Yeah, I don't think there's anybody there's no one state agency that's responsible for any of that.
And this has been tough also, not just the state of Texas, but on the national level too.
Yes.
I think so far, who's cared most about this? One of them was actually the National Academy of Science. That's why I think back in 2016, when I kind of threw my random idea out, they were like, yeah, we should go for this. And this is the future. But I think this is, again, well, I guess hazards in general, right? People don't like them. Either earthquake or sea level rise. People don't want to be told, for instance, your home is going to be flooded 10 years from now, and your property value is going to decrease substantially and all that. So it's been very tough. But I think increasingly there are more and more efforts. So for instance, federal efforts, I guess, from the data perspective at least, NOAA is responsible for a lot of the tidal gauges. NASA is responsible for a lot of the satellite observations, which we basically use a lot of their satellite data, like JSON 1, 2, 3, and or the GRACE data, GRACE FO, and all that, ISAT 1 and 2, to inform our analysis. So I think some of those, hopefully, really, I'm hoping in the near future, all the different agencies could kind of gel together. And that was also one of the discussion we had. Previously, I was serving on the community resilience panel back in 2015 to 2017 as Secretary of Data, Metrics, and Tools. There we talk about sort of like system level of treatment, so across different sectors and also interagency efforts. So back then, I think there is also various agencies, including a National Institute of Standards and Technology, more in terms of the application side, and FEMA also. So we hope that some of that effort now is hopefully getting reactivated again and going forward.
Yeah, I mean, obviously USGS also is involved in some of that with respect to wildlife and cultural resources. But yeah, I mean, even within the climate aspects, there's not a lot of state capacity to deal with some of this because the interactions and the understanding of that information is more at the local stakeholder level than aggregated at the state level, right? Yes. Yeah, and I think we as a society have not figured out how to integrate the information, because one of the things you mentioned too is the critical stakeholders that need this information, and then how do we as scientists develop the co-production of it that's really going to solve problems, and not just provide another publication that doesn't get used.
Yeah, kind of the eventual impact and then benefiting the communities that are most impacted. Yeah.
Right. Yeah, because one of the things I learned out of the Louisiana group is the groups in Louisiana that are going to be the most impacted within the next 10 to 15 years are the indigenous tribes in Louisiana, because they're all coastal. And they are already looking to resettle some of them because of current sea level rise and the impact of the hurricanes, allowing that to occur at a much more rapid rate for wiping out a lot of the seagrass areas and simply erosion. And then also the settlement of the coastal areas from withdrawing gas and oil.
All of that together.
Yeah, all of that comes into play. That's exactly right. And yes. So you raise an interesting question at the end, let's increase the frequency, intensity, and duration of technical and philosophical discussions. I'm curious because we've tried this in the Climate Center over the years, and I know Hong, as a longtime faculty member in biological sciences, has had some discussion on other aspects. As how do we change how we educate students to not be iterative, but to sort of think broadly?
Yeah, so I guess kind of some of the efforts that I had for my classes, for instance, both the undergraduate and the graduate level, is trying to maybe just introduce what we're experiencing to them right away. So for instance, when I was deployed for the reconnaissance efforts for Hurricane Ida, basically that hour after we're already working on it. At the same time, I'm in parallel writing up my new structural reliability homework assignment.
Mhm.
So the students can basically do that at the same time and think about issues like this. And part of it, this discussion actually with the students when we were in class, include some students say, oh, this sounds like the day after tomorrow. And that was our class discussion. And guess what? The next day, we have reports, images, and videos from New York City that looks just like that. So I think some of those really impacted our students. And same thing with a lot of those events, like say the wildfire in California, where you look almost, the sky almost look Martian.
Mhm.
And also pandemic, what we're experiencing right now. So I think a lot of those could be lessons for our students here. That's kind of the catastrophe piece. But in terms of the innovation, advanced technology piece too, that could also be motivating, because I also try to incorporate some of that, like the National Academy's efforts, and also the Structural Engineering Institute effort, Vision for the Future 2033 kind of thinking,
Mhm.
instill those in the students and let them imagine kind of what is the future, because they will be the future.
Yes, yeah, and part of it is allowing them to know what those opportunities could be, because as you know, students nowadays come into the university with sort of preconceived, what I would call somewhat tunnel vision of what a university is about, without allowing themselves to experience what it could provide them.
Yeah, and also encourage them to venture out. Like, oh, I did for my students too. I think I am very often the odd one out, like in Copenhagen, probably the only known climate scientist. And then same thing for my students. I encourage my student, Matt Thomas, for instance, to apply for NASA JPL summer school on climate science and solar observations. And he's basically the only engineer there among a group of climate scientists and kind of PhD and postdocs. And same for Nana BRH. So he's the only engineer also in I think the summer school in Japan for earthquake science. So I think when they go out, when they venture out of their comfort zone, really it broaden their perspective and think about it in an innovative way. And could contribute to both fields, I think, back and forth.
Yep. One of the things that someone asked is whether or not in understanding these sea level rise impacts, obviously it's not going to be uniform across the planet. It's going to have, right? And so the question is, what parts of the planet are pretty much in dire straits now versus those that have some time, or how do you talk about that going forward?
Yeah, it's a very, very tough question. And that's why a lot of the projections right now is not just on the global scale, but more and more regional. And that required also a lot of the modeling effort too, in terms of higher resolution models that inform more local decisions. And regions, so there are really quite a lot of regions, if you will, sort of already suffering quite a bit. I think from what you mentioned earlier on, Louisiana and some of the islands are already, if you will, a lot of them are already sinking, and kind of some of those homes are no longer habitable. So they have no choice but to retreat. Whereas some other areas, so we probably still have some time. So time here is really critical. So I really hope that with this kind of research and also education outreach, and hopefully soon interagency efforts on a big scale, that we could all act together sooner than later.
Yeah. So for those on this Zoom meeting, one of the people we had talk a while ago was Christine DeLong of LSU, and she looks at ancient forests and underwater events along with corals, but she found a cypress forest that was 50 miles into the Gulf that they've recently discovered and published on. So you can see how much sea level has changed within that Louisiana area, where the forests were growing 50 miles into the Gulf. And you can imagine what a sea level rise of 50 miles along the Louisiana coast, what impact that would have.
Yeah. And something also for like the Houston flooding problem too. So like that, not yeah, that's kind of the other extremes, right? Or the other weather extremes and all that. It's basically if you look at the hazard curve, you look at kind of what FEMA thought was like the flood zone before. If you look at it now, the updated one that my student was looking at is pretty much so extensive. Like whichever homes were not in the flood zone before now are underwater.
That's exactly right. Yes. Well, folks, we have come to our 6 o'clock hour, and to let you folks get off to have supper and into your evening. But we want to thank Dr. Lin for very much for this exciting and informative presentation to bring our science by the glass to a conclusion for 2022. So please join me in thanking Ting for this presentation.
Thank you.
Yep. So thank you all for attending. Please keep in touch. We will be sending out information related to what goes on for us in September and other updates as we proceed in through the summer. Also, you know, this question about hazard mitigation, how to be prepared. The National Wind Institute has information on tornadoes and what you need to do to prepare for tornadoes. So please look at that information also if you have not.
Speaking of which, the National Wind Institute next week is going to be packed with events. The one is the Wind Conference here, hosted here in Lubbock next week-long conference. Before that, there is also TEMIST, the Texas branch of the National Academy of Science and Engineering Medicine. There is also a workshop focusing on natural hazards. So for those of you who are local, look them up and hope to see you there.
Yes, for sure. Well, thank you all very much. Enjoy your evening. And Dr. Lin, thank you much very good to be able to do this. And we'll be looking forward to seeing you on campus.
Thank you all. Appreciate it, Dr. Zhang.
Thanks all.